Before starting the lesson, try this warm-up. When adding exterior angles to all corners of a shape, you can only add one to each corner, and they all have to go the same direction. So I have three drawings here, and my question is, which drawing is correct based on this description here? So pause the video, see if you can answer the question, and then check back in here to see how you did. This drawing is correct because all the exterior angles go in the same direction. Remember I said in the last lesson, the exterior angles have to go in a kind of a saw blade pattern where they're all going in the same direction. This is also correct. All the exterior angles have extensions going in the same direction. This is not correct because it doesn't follow the same pattern. In the last lesson, we looked at angles in triangles, and now we're going to extend that to angles in quadrilaterals, so four-sided figures, and also just polygons in general. Polygons are just shapes that have several sides, any sided shape. Now I want to demonstrate something to you, and it's going to take a couple minutes for me to prove my point here, but as you watch, just try to make sense of what I'm saying and try to follow along, and then I'll wrap everything up together in a nice bow later on. But for now, just watch and listen and try to make sense of what I'm saying. Here I have a triangle. There are three sides, and what's the sum of the interior angles? Well, we already know this from the previous lesson. We know that the sum of the interior angles is 180 degrees. This is the basic information that I'm going to use to prove my point as we move to bigger and bigger shapes. So just remember, the sum of the interior angles in a triangle is 180 degrees. Now here I have extended to not a three-sided shape, but a four-sided shape. Here we have a square, and I want to know what's the sum of the interior angles in a four-sided shape. Well, you may already know this, having learned it in a previous class or something, but if you don't know it, you can figure it out as long as you know this rule about triangles. Watch this. I can cut this four-sided shape into two pieces. Now each piece is a triangle. I also know that the interior angles of a triangle add up to 180 degrees. So in the first triangle, I have the angles shown in red. In the second triangle, I have the angles shown in blue. The red angles add to 180. The blue angles add to 180. Together, all these interior angles add to, well, 180 plus 180. That's 360 degrees. So we can say that the sum of the interior angles for a four-sided shape is 360 degrees. Now what about a five-sided shape, a pentagon, or a six-sided shape, a hexagon? I can do the same thing with my pentagon. I can cut it up into triangles. So in this case, I can cut it up into three triangles. The interior angles of each triangle add to 180. These three angles add to the entire interior angle for the pentagon. These two add together. These two add together. So if I add up all of these interior angles, I will get the sum of the interior angles in my pentagon. So I have 180 plus 180 plus 180. That ends up being 540 degrees. And hopefully you can see the pattern now with my six-sided shape, my hexagon. I'm adding another triangle. So this time I have four triangles that it can be cut up into. Each has interior angles adding to 180. So if I want the sum of the interior angles of the hexagon, I'm basically just adding up the interior angles of four different triangles, and that ends up being 720 degrees. So just to recap, for a three-sided shape, the sum of the interior angles is 180 degrees. For a four-sided shape, it's 360. For five sides, it's 540 degrees. For six sides, it's 720 degrees. So every time you increase the number of sides by one, you increase the sum of the interior angles by another 180 degrees. So let's think of a general rule. To calculate the sum of the interior angles in an n-sided polygon, so n just represents the number of sides. Well, in order to figure this out, maybe it'll help to make a table first. So here I have the number of sides in my shape and the sum of the interior angles for that shape. Three-sided shape had 180 degrees as the sum of the interior angles. Four sides, 360, five sides, 540, six sides, 720 degrees. What's the pattern? Every time you increase the number of sides in your shape, your sum of your interior angles increases by 180 degrees. So we can think of it as the sum of our interior angles is 180 multiplied by something. Well, is it 180 multiplied by the number of sides? Well, if that was the case, then for a three-sided shape, the sum of the interior angles would be 3 times 180, which would be 540 degrees. But that's not what we see. So what are we multiplying by? We need to make some sort of an adjustment. For a three-sided shape, we're multiplying 180 by 1. For a four-sided shape, we're multiplying 180 by 2. For five sides, we're multiplying 180 by 3, etc. So really, we're multiplying 180 by the number of sides minus 2. This is a formula that describes the sum of the interior angles for any polygon, where n represents the number of sides in that polygon. In your notes, put a big square around this with stars and exclamation marks. You need to know this. It's very important that you remember this formula to calculate the sum of the interior angles in any n-sided polygon. Now at this point you might be wondering, what is the sum of the exterior angles? In our warm-up we looked at exterior angles, so what about those? Well, if you're really interested, I can show you how to come up with this, but just for the sake of time, all you really need to know is that the sum of the exterior angles for any polygon is 360 degrees. Again, it's 360 degrees as the sum of the exterior angles for any polygon. That means triangles, quadrilaterals, pentagons, hexagons, anything. It's always 360 degrees. So here's an example. How many sides does a Loonie have? Take a look. How many? Pause the video if you need to count. If you count them up, it has 11 sides. And if you're interested, the name of that shape is a hendecagon. Now, is it a regular shape? How do you know? Well, what is a regular shape anyway? A regular shape means that all the sides are the same length and all the interior angles are the same angle. So is this a regular shape? Well, it looks very symmetrical, so I would say probably yes, because all the sides are the same length. And what is the sum of the interior angles? Well, I'm glad that we went through that exercise to figure out the formula for that. We know that the sum of the interior angles is 180 times n minus 2, where n is the number of sides, which means that the sum of the interior angles for a Loonie is 180 times 11 minus 2. Well, 11 minus 2 is 9, and 180 times 9 is 1,620. So the sum of the interior angles for a Loonie is 1,620 degrees. But what is the size of one interior angle? We know the sum of all 11 angles is 1,620 degrees, but what is just one angle? One angle here. Well, it looks like it's an obtuse angle, more than 90 degrees. So we have a rough idea of what it should be. If we take the sum, the total of all the angles, and divide it into 11 pieces, we can find out how big one of those angles is. So 1,620 divided by 11, it's about 147.3 degrees. In this example, we're to determine the angle measures indicated. Okay, so in the first example, we have a four-sided shape, and this angle is the one I'm trying to find. So to solve this one, I'm going to use the sum of the interior angles for a four-sided shape. Well, I can use my formula, 180 times n minus 2. N is 4 because there's four sides to the shape. So 180 times 2 is 360. So I know the sum of the interior angles in this shape is 360 degrees. Well, what is the sum of the interior angles? What's x plus 110 plus 50 plus 140? So that equals 360 degrees. So to solve for x, I just have to subtract all of those angles from 360 degrees, and I get x is 60 degrees. Now do the same thing for this shape. Pause the video, try to figure out the measure of angle x, and then check back in to see how you did. I used my formula, 180 times n minus 2, counted the number of sides. There's 7 sides, so n is 7, which means inside the brackets is 5. 180 times 5 is 900. So the sum of all of these angles is 900 degrees. If I subtract all these angles from 900, I'll end up with my value for x, which was 90 degrees. These next two figures require you to use exterior angles in your solution. So for the first one, you want to find angle x, which is an exterior angle, and you want to find angle y, which is an interior angle. For the next drawing, angle x is an exterior angle, angle y is an interior angle, and this is a regular shape. Notice that all the sides are the same length. So pause the video, try these on your own to find the missing angles, and then check back in to see how you did. For the first one, I used the fact that all the exterior angles add up to 360 degrees. That's regardless of the shape that it is. So they all equal 360 degrees as the sum. So to find x, I just have to subtract all these other exterior angles from 360, and I end up with x is 80 degrees. Angle y is on a straight line with this 130 degree angle, so they have to add up to 180 degrees, which means y is 50 degrees. Over here, because this is a regular shape, all sides are equal, I know that all the angles are equal. All the interior angles are equal, and all the exterior angles are equal to each other. So if I start with my exterior angles, I know that they all have to add up to 360 degrees. I have 6 of them, so 6 times angle x is 360 degrees. To find angle x, I just have to divide 360 by 6, and I get 60 degrees. Now if x is 60 degrees, and y is on a straight line with it, then y has to be 120 degrees. Now this example uses a few different angle properties that we've looked at in this topic, and I just want you to notice that you have some parallel lines here. So remember your parallel line theorems and see how you do with this one. So pause the video, try it, and see how you do for finding x, y, and z. I started with my parallel line theorems, and I noticed a couple different ones. I have an F pattern here, So this angle y is the same as the angle down here. I also have a z pattern. So this angle z is the same as this angle here. And then I also have opposite angles here. So this angle z is the same as this angle here. And then I just tried to figure out one of them. So I noticed that angle z is on a straight line with the 105 degree angle. So 180 minus 105 is 75 degrees. So that's what angle z is. And remember, that's the same as this angle. That's the same as this angle. Because now I have two angles inside this small triangle, I know they have to add up to 180. That means y is equal to 180 minus 15 minus z, which was 75. So that leaves me with angle y as 90 degrees. Now remember, this 90 degree angle, this angle y, is the same as the angle down here. So angle x and angle y are on a straight line. They have to add to 180. So x is the same as 180 minus whatever y was, which was 90 degrees. That means x is also 90 degrees. For the last example, a regular tridecagon has 13 sides. What is the measure of each exterior angle? Well, don't freak out with the enormous size of this shape that has 13 sides. Remember, we're talking about exterior angles. We know that the sum of all of the exterior angles is always 360 degrees, no matter what the shape is. So if we want to know the measure of each exterior angle, we just have to find the measure of one exterior angle. Well, they total 360 degrees. So we just have to take 360 and divide it by 13. And that ends up being about 27.7 degrees. So that would be the measure of one exterior angle. So the important takeaways from this lesson are you really need to know your angle properties. You need to know the sum of the interior angles for any shape. That's that formula, 180 times n minus 2. You also need to know that the sum of the exterior angles is 360 degrees, no matter how many sides the shape has. And then you still need to know all of those parallel line theorems for those different angle properties. And that should help you out to solve a lot of different geometry problems. If you have any questions, please let me know. Otherwise, move on to the practice questions.